We're here at the NVIDIA booth. My name is Edward Richards. I'm a Director of Solution Architecture. NVIDIA's had a long relationship with Teradici and a long relationship with Google. Teradici is by far our preferred method to connect to Google sessions of virtual desktops. In fact, just today we're announcing general availability of our T4 little form factor compute card that's also capable of doing ray tracing, a great thing for media and entertainment. And we're announcing virtual Quadro Workstation. In fact, we even got the Partner of the Year award from Google for that launch. This allows you to have professional graphics workstation cards in the cloud as a virtual Quadro workstation. And the way you would typically connect to a desktop like that is with the Teradici agent to have the most streamlined, lowest latency, cleanest experience that you can possibly have. So this is the Tesla T4. It just went into general availability today at Google. It's a little form factor. It's the data center version of what you would have as a professional graphics card in your workstation, whether you're in architecture or media and entertainment or CAD design. This is the sort of thing you would have to accelerate your professional ISV application. And this is the data center version of that. It has ray tracing. It has the artificial intelligence core called the Tensor Core in it. And of course it has a lot of compute in there, 3,500 CUDA cores. So it's called the Tesla T4. And with that, what you can do is you can fire up a virtual workstation. And we actually have a demonstration of that here. We have the new virtual Quadro workstation. This is a Teradici client connection to an instance sitting in US West. And we have a Windows desktop there. We have Maya installed. And we have our little speed of light guy that we call Sol as a demonstration asset. And what we're seeing here is the typical Maya experience where you would have the meshes, and we're previewing with the ray tracing turned on using the Arnold renderer. Arnold is a ray tracer that comes from Autodesk that's used as a backend. So at the moment we can see a drawing, and I can skip to a different frame, for example, and it's resolving the rays. Everything is bouncing and bouncing and bouncing and bouncing, scatter, 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 and reflections and absorption. And what we get is a ray traced result of Sol, so that someone who's doing creative work on the system can change the lighting, change the material qualities of how it's bouncing, change the scratches and dents. You can see finger marks here in the helmet where there's some smudge marks from the hand. And it's pretty much interactive. If you want it to have even more interactive, what you can do is you can actually have 4 cards in a system and get 4 times the performance. So this little guy is amazingly powerful for what it can do at its size, and gives you a remote experience that you would otherwise not be able to have in this new field of the very heavy computation of ray tracing. It also has AI. So that Tensor Core chip that I mentioned, we actually have a noiser on here. I can't find the menu, but waiting for a ray tracing to resolve all the way can take probably 6 seconds to get to a good image. And what you would like to do for interactive is get it down to maybe 1 or 2 seconds to resolve. And using artificial intelligence, we have a smart denoiser where the AI will interpolate and work out what that image will look like when finished. It's more than just a smudging tool to smudge out pixels. It's actually using AI to predict what that image is going to look like based on the environment that it's seeing in front of it. And so it's a way of cheating ahead. It's a classic example of how NVIDIA innovates by taking components of otherwise different ecosystems and working out how to have them work together. So in this case, we're using the CUDA cores, we're using the ray tracing cores, we're using the tensor cores for artificial intelligence, and we're using our video encode cores, the NV encoder, to do hardware video encode to then hand that off to the Teradici client to get that data to us, using up as much of the chip as possible so you get the best value.